So in OSI layer, layer 2 comes first, then only 3, 4, 5 will go. The firewalls which we have provide security from layer 3 and above or 4 and above, layer 4 to 7 or 3 to 7. Because there are routed firewall as well as transparent firewall. If it is transparent firewall, you can have from layer 2 itself. But again, firewall is an additional expenditure. We can provide a lot of we can have a lot of security features enabled right on the normal layer 2 switches, so that we can even manage without a firewall. We can make a switch as a very strong firewall. If we know this chapter, we'll be able to mitigate thousands of attacks. It may look like simple chapter, solutions are simple, but the result is big. There are a lot of vulnerabilities which we are going to discuss, where we need to put some mitigations so that that vulnerability will not be there in our network. For example, all the switch port interface, switch ports are in an access mode. You remember, we saw the admin
Yeah.
mode will be dynamic auto. If admin mode is in dynamic auto, what will be the operational mode? Access. Access. Dynamic auto, administratively dynamic auto, operationally it is going to be access.
Access. Yeah.
But if someone comes and negotiates trunk, it will turn itself as trunk. The port role will change from access to trunk. This is a vulnerable place. Leaving a port auto is not good, because at any time someone can come and negotiate trunk, and they can know all the VLANs that you got. They can know all the VLANs that you got, and they can hop between the VLANs. Yes, there's an attack called VLAN hopping attack. Someone can enter with multiple tags. First tag VLAN 10, so the packet will go to VLAN 10. Then when it come out of VLAN 10, the top tag will be VLAN 20. Then the same packet will go to VLAN 20 also. VLAN 30, VLAN. So you can do multiple taggings using some attacking tools. See the problem, just one command you should have typed. What? Switch port mode access. Because you have not typed switch port mode access and hard coded it as access port, big attack is possible. It's an attack. Someone getting into all your departments, all the VLANs, is definitely an attack. To achieve that, all that he needs to do is he needs to negotiate trunk and try one VLAN number after the other. The total number of VLAN is only 4096. Everyone knows. On Earth, no switch have got more than 4096. In that, there are some reserved VLANs. Apart from that, attacker is going to try all other VLAN numbers and get into your business. Is going to be a part of various broadcast domains that you have. So, simple command switch port mode access would have prevented this VLAN hopping attack. Switch port mode access. Or if there is a port unused, instead of leaving it as auto, shut down. Put them all in a VLAN which we don't use and shut down all the ports. This is very safe. So layer 2 is the place where many attacks happen. For preventing such attacks, you really need not to buy a firewall. If you'll stop attack right in layer 2 itself, there is no need for the firewall to mitigate, because right in the root itself you have cut the attack. It won't even hit the firewall. Right in layer 2 itself you identified as the attack. Only very few will be managing going up to layer 4 and firewall will stop it. So providing security on layer 2 is better than going and tuning firewalls for preventing layer 2 attacks. You don't need to tune layer 2 attack mitigation on firewall. You can just do it on switch. Maybe for deep packet inspections, like inspecting the payload, you may use firewall. So in this chapter, we are going to see different ways in which the data theft happens, loss of denial of service happens, and we are going to see how to minimize the loss and how to minimize the data theft. Yeah. So this picture shows that right in the access layer, the attacks are more. What do we have in access layer switches?
And
So
end devices.
yeah, that is edge and DMZ. Anyway, you're going to have firewall on the edge. More attacks are happening from within the company. Someone is already inside your company who is connected to your access layer. Attackers will try to first get inside your network. After getting in, they will go through the access layer to attack. That's more easier for them. First, they will somehow know your credentials, do some VPN. They will, even if they're coming from outside, they will pass through the firewall successfully by putting some credentials that they have stolen. Once they get inside the network, they will be here in the access layer. From the access layer, they can jump between various VLANs. See, all the end devices are connected to access layer. The servers, where the data are kept, everything is in access layer. So the attackers will be focusing on the access layer. The attacker within the organization, the attackers coming from outside, they will all first try to go to the access layer where the servers are connected. Databases are connected. So if you will protect the switches, if you will put some firewall features on the switches to identify the attacks and stop right in the access layer, then there won't be much work on the core layer, on the DMZ and the edge. to mitigate. So most of the attacks are mitigated already. Here is some of the rogue device, some of the vulnerable device in a network. A layer 2 switch can be used to attack us, or someone may use a wireless access point, which we already having in our network to penetrate. Someone may be using the old bridge or a hub kind of device. These are all the devices that you will find in the access layer which are vulnerable. Now, when we talk about switch attacks, we can categorize that in these four categories. Switches use MAC address. So there are some MAC address based attacks, MAC layer attacks. Switches have different broadcast domain. We call them VLANs. So we have some attacks based on VLANs. I gave you an example. VLAN hopping attack. And we have DHCP. We have ARP. This all do what? They do layer to broadcast. Because it's a layer to broadcast, someone can spoof. For example, I'm asking, hey, hello, DHCP server, do you see me? This is my MAC address. Do you see me? And the attacker DHCP saying, yes, I see you. If you want, I can give you this IP address. What do you say? A proposal will be given. We call it as offer message from DHCP server. So before the genuine DHCP see my broadcast, before the genuine DHCP provides me an offer, the attacker is going to spoof like my own DHCP and say, may I help you with this address? And my PC says yes. And an IP address is now received in my PC, not just an IP address and subnet mask, even the gateway is provided by the attacker's DHCP. So now, according to me, I'm going online, but I'm going online via the attacker's network. Now, attacker can see everything. This is what we call as man-in-the-middle attack. Spoofing is possible in layer 2. Broadcast, layer 2 broadcast is bad. ARP does layer 2 broadcast. DHCP does layer 2 broadcast. So in all this, because there is a layer 2 broadcast asking, hey, is there anyone with this MAC address? Sorry, is anyone with this IP address? May I have your MAC address? ARP does a layer 2 broadcast saying, is anyone with 10.00.10? Then one bad guy says, I am 10.00.10. My MAC address is alpha, alpha, alpha. But he is not really 10.00.10. He is actually 10.00.100. He is spoofing as 10.00.10 to do a man-in-the-middle attack. These things need to be prevented. The spoofing attack. So, the fourth one is switch allows you to tell that if anyone comes with so-and-so username and password, he can take control of the switch, which can be a vulnerable approach. Why? Because if someone stores my username and password, he can tell it from anywhere. That's an attack on the switch device itself. Now, how to prevent this? We can write an access list saying only these addresses are allowed to use the VTY session. Only these devices are allowed to, only from this particular IP address, only from this particular subnet, someone can tell. And it is not that anyone and everyone who has got the password and the username can tell that. He also needs to come from such and such address and subnet. This is what we call it as attacks on the switch device. See, CDP is also a dangerous one. Cisco Discovery Protocol. We think that CDP is good. Why? Because we discover our neighbor devices by typing show CDP neighbor. So that you no need to go to that neighbor device to know about the neighbor. Sitting on this device, you can see the information about the other switch. In Cisco, both routers and switches, we have CDP enabled by default. Have you used CDP?
Yeah.
Yeah, all of the time.
So to see who's connected to
Which
the switches.
interface, which port he has connected, what is the capability of the connected device. If it is R, then it means router. If it is yes, which means it's a switch. If it is yes/R, which means it's a layer 3 switch. It can do switching as well as routing. So you will have very um, uh, clear information about the neighboring device, including the host name, the MAC address, the IP address. You can see, which can be also used in a wrong way. If I want to attack my neighbor device, that information that I see there is more than enough. If I can know his MAC address and IP address, I can finish him. So CDP sounds like good, but not good in all places. So wherever you don't trust, on those interfaces, we have to trim CDP. We need to disable CDP. CDP can be disabled per interface, can also be disabled per device. You can disable CDP on all interface of the device. You can also disable CDP per interface. So these are all the things that we are going to focus on this chapter. Here what we see is a MAC flooding attack. You see, every switch has got a limit of buffer. Every switch will have a space where the MAC addresses can be stored, which will decide the forwarding decision, filtering decision, which we learned in the beginning days. Switch listens to the port, learns the MAC address. As a result, switch is called as an intelligent device. So if any packet wants to go to a destination, there is no need for a broadcast because you know the destination. You can directly forward the packet to that destination. So switches are more clever because they know who is connected where using the MAC address. But it cannot learn unlimited number of MAC addresses. There is a capacity, there is a limit. Not same on every switch. For enterprises switch, there are various series of switches. Every series will have different limits. Edge devices will have more. Service provider devices will have much more. So there is a limit, that's what I want to say, because every switch have got different number. You need to check the data sheet for that. What I'm trying to say is, if 1 million MAC address comes to a switch, don't expect the switch to learn all of them. Whatever the capacity the switch has got, only within that level, it can learn MAC address. So the attacker knows this. Attacker knows that the switch has got some limit. If you exhaust it, if you will consume the entire space, the switch will start malfunctioning. The attacker knows this. So now what he does is he tries to fill the space, the MAC address space, the MAC table space, by flooding MAC address. Yes. In a port of a switch, any number of MAC addresses can be learned by default. Any number of MAC addresses can be learned in a single port. If I send 1 million packet with 1 million different source MAC address, against that port, 1 million address will be seen in the MAC table. What I'm trying to say here is, attacker is going to use this as the chance. So what attacker does is, if you see here in this picture, the attacker PC Mac C, he has got some special software. This type of attacking tools are freely available in the internet. Small piece of application. Mac flooding attack, that's all you need to search. You install into your laptop and then double click, it will start shooting out packets with different MAC addresses, X, Y, Z, It sends, actually, one computer will have only one MAC address. But this attacker PC generates different type of MAC address in thousands, in few seconds, thousands. As a result, the CAM table, the MAC address table, is full. You see? Attacker floods the CAM table with frames with numerous invalid MAC address. As a result, the MAC table is full. If MAC table is full, there won't be any more space for new, genuine MAC address to be learned. In this situation, whatever the packet that comes in from the genuine computer will be flooded, because the destination address to which the genuine computer wants to go is unknown. See, for example, A wants to go to B, but there is no B in the MAC table. Whenever the destination is unknown, what switch will do? Flood it. Flood it. Whenever there is no MAC address, whenever there is no destination MAC address, switch will flood. Even if there is a MAC address space, if you are pinging someone for the first time, switch may not have the information about that destination. So flooding happens. That is one real world, that is real scenario. This is attack scenario. Attacker has intentionally made the switch not to learn any MAC address by consuming the CAM table buffer. So when A comes, A's MAC address is luckily learned because there was some space, but it wants to go to B. There is no information about B in the MAC table. Switch floods. And it will be flooding as long as the MAC table is full. So all the flood packet goes to everyone in the network. As a result, the network is going to be slow. Not only that, attacker is getting a copy of every packet that goes to B. This is what he wants to gain. Attacker, the reason why he was doing MAC flooding attackers, he wants to listen to every conversation that goes between A and B. Here we just got A and B. In the real world, it will be many genuine A and B. An attacker sitting as an employee or a guest of the company, he is now knowing all conversations. You might have seen such thing in movies. Whenever I go to that finance related offices like banks and that Nifty, whatever that in Mumbai, what the census, they are very strict. They're always behind me, especially because I'm a network trainer. Very strict. They don't give me internet access. They don't give me any free. They want me to train them, but they don't give me. It's good actually. What they are doing is good.
Yeah.
So no one will be able to listen to the inside conversations if you can mitigate this attack. MAC flooding is a dangerous attack. Normal traffic is flooded out, all the ports, no CAM entries exist for the genuine host. The reason is the MAC table is full. Now, how do you prevent this? Simple. There is a Cisco solution to this called port security. Port security is going to all the ports and setting the limit of how many MAC address in this port is expected. See, by default, unlimited number of MAC address can be learned in a port. That is the problem. That is the problem. Because the vendor also do not know how many MAC addresses will come on the port because they don't know how you are going to use the switch. What if you connect one switch to another switch? Then all the devices that are in first switch, their MAC address will reflect in the trunk port of the second switch. So the vendor also do not know how many ports are going to be, how many MAC addresses are going to be on each port by you. So they leave it like unlimited. That is what attacker is using. See, it's a vulnerable place. We can mitigate it by setting the limit to each port. When I enable port security, first thing what I need to do is I need to configure that port as access or trunk. Repeating again. You cannot enable port security on a port which is dynamic auto. You cannot enable port security on the port which is dynamic auto. Yeah. So we enable port security. First of all, we should enable access on front port. Then you go and enable port security by typing the command switch port security. That's all. Switch port security. When you say this, only one MAC address is allowed on that port. What if more than one MAC address come? If more than one MAC address come, the port will go to shut down mode. That will be considered as violation. When you enable port security, only one MAC address per port is allowed by default. So when there is a second MAC address comes, the port is going to shut down to protect your MAC table buffer. What if I want 3 MAC addresses to be allowed on the port? You can set. For example, if I connect a switch to another switch, the first switch may have 3 computers. So when I connect that first switch to the second switch, I need to allow 4 MAC addresses. One is the MAC address of the first switch. The other 3 is the MAC address of those 3 devices that are connected to the first switch. So what I'm coming to say is port security by default will say allowed MAC address is 1. But you can optionally go and increase the number of MAC addresses that can be learned on that port. There is also another option. What? You can clearly say what all those 3 MAC addresses that you want to allow. Or if it is one MAC address, you can say which one MAC address is expected. If any other MAC address comes other than what is expected, port will be shut down. So, see, the port security not only allows you to set a limit, it will also optionally allows you to give those MAC addresses that are expected. What if, out of 3 MAC addresses, I know only 2 MAC addresses. I don't know the third one. It is okay. You can give the 2 MAC address and you can ask the switch to learn the third one dynamically and stick it. Stick it permanently. See? So even if you restart your switch, the MAC address will not get vanished. The MAC address that you binded will remain there. We are going to see all these things now. Port security is the solution to mitigate MAC flooding attack. Do you have any question?
No, sir.
Port security is a Cisco's feature. The other vendors also got the same feature but with a different name. In Cisco, this is the name, port security.
Yeah.
There they may call it as MAC binding, something like that. Every vendor have got its own name. MAC flooding attack is just sending different MAC addresses in a very short period to a port so that the buffer will be fully consumed and switch will start flooding because the destination is not seen in the MAC table. To avoid that, we limit the number of MAC addresses that can be learned on each port by setting port security. If you don't mention how many MAC addresses, the default is going to be 1 MAC address per port. So the attacker now cannot succeed. When an attacker comes with an attacking tool, the first MAC address, fine, accepted. Second MAC address, boom, the interface is down. Attack is mitigated. Attack is prevented. Okay. So port security is a solution. Now, with the port security, you can limit the MAC addresses. You can also specify which MAC addresses are allowed. You can also specify the action need to be taken if the violation happens. There are three actions. The default is shut down. For example, you said three MAC addresses are allowed. When the fourth MAC address comes, the port will go down. So now the three genuine MAC addresses will also be prevented because you have shut down the port. But the fourth MAC address comes. When I have allowed only three MAC addresses, when the fourth MAC address comes, when the fourth MAC address comes, the genuine 3, which was using the port, will also be denied because the port goes to the shutdown state. To bring it up, the administrator needs to manually log into the switch interface and say shut down once and then say no shutdown. I repeat, if the port is shut down because of violation, to bring it up, first of all, we need to shut down manually by getting into the port and say no shutdown. When you say no shutdown, again, if it finds 4 MAC addresses, again it will go down because you have set limit to 3. Then you need to again go and say shut and no shut. You can also automate this by enabling something called error disable recovery, which we'll see later. Now let us focus on this. Instead of shutdown, there is also restrict and protect. What it is, when you enable protect mode, violation mode as protect, instead of shutdown, shutdown is default. Instead of shutdown, when I say protect, what it is going to do is, when the fourth MAC address comes, it will ignore those fourth MAC address packet. Meaning the first 3 MAC address packets are allowed to communicate continuously. So what I'm trying to show here is without interrupting that first 3, you can mitigate. When you say 3 MAC addresses allowed, the first 3 MAC addresses conversation will not be disturbed when the fourth MAC address packet comes because you have enabled protect mode. When you enable restrict mode, you're not only protecting, you will be able to restrict it from happening because you can keep an eye on the number of times that happens. Meaning, when you say restrict, you will have a syslog, you will have a log generated saying these many packets are violated. If 10 packet violated, it will show 10 packet on which port and how many. Which port and how many packet violated. So that you can keep an eye on that port and take some action. So you get a proof to say from this MAC address, these many packets have come in the restrict mode. In the protect mode, you just protect it. You ignore the fourth packet and protect. In the restrict mode, you not only protect, you also have a log. You also have a proof to say what is causing this. Who is causing this? Or which MAC address is an attacker? So you can enable port security by giving this command switchport port security. This command will enable port security. And then optionally you can go and say how many number of MAC address that the port can allow. And optionally you can also say the violation actions. This is the verification command, show port security. Here I can see the port security is enabled only on these 3 ports. And the maximum address allowed is 11. And currently all 11 is consumed. All 11 addresses are learned. Here maximum is 15 and currently 5 is learned. Maximum is 5, currently 4 is learned. So far no violation happened. In the first port, what they have done is, in case if violation happens, the default is left. The second one, restrict, is done, which will increment the log. The third one, protect, is enabled, which will ignore the violating packets coming in. It will just ignore. Means it will just filter out. It won't allow it to come in. Alright, you can also type this command, show port security, and then the interface name, C51/0. Maximum number of MAC addresses is 11. Current learned is 11. Manually configured MAC address. Out of 11, 3 is configured. After 20 minutes, the learned MAC address will time out if there is no communication. If it is inactive for 20 minutes, it will time out. It's aging 20 minutes. So far, no violation happened. Show port security addresses will show you what all MAC addresses on which VLAN, on which port. See F1 5/1, 5/1. There are 5 MAC addresses in which these 2 are learned dynamically. These 3 are configured statically, manually fed. Now, if you're manually adding the MAC address, there are 2 ways in which you can add the MAC addresses. You can tell port security that these are the MAC address you are supposed to allow. One, if you know the MAC address, you type those MAC address. The other one, in the secured environment, you can enable a keyword called sticky. So in a secured environment, when the conversation happens, the MAC address will come and get sticked permanently to the NB RAM. So when you shut down the switch, the MAC address that you want to allow will be still there. Even when you reload, the MAC address will be still there. And it will be checked against the packet that enters in even after the reload. We call it a sticky. Now, we have to do this lab port security. Before that, do you have any question on MAC flooding attack and the mitigation called port security?
No, sir. I'm clear with that.
Right. On switch 1, we got only one computer whose IP address is 10.0.0.3 is connected. This is the very first time, we are checking this MAC table in this lab. We already see, even though it's the first time, we already see the MAC address learned. On F01, this is the MAC address of this computer. And this is the MAC address of this switch. How do I know? Go to the switch and see. On the second switch, when you type this show spanning tree, you see the MAC address is ending with A834. And if you go here, sorry, that's this there. F02, I see different MAC address. Okay, this MAC address, let's verify this PC now. If config /all, the MAC address
Yeah, that's the PC.
PBC92. BC92. And we need to find out whose MAC address this one is. Is even the switch have got a MAC address, but I don't see that MAC address. It is beginning with A. We'll find it out.
You're recording this session,
Yeah,
isn't it, sir?
okay. And on this switch, let's go to the second switch and see the MAC address table. Show MAC address table. I see already there are two MAC addresses. There are already two MAC addresses on the same port. This F01 is connecting to only one switch. Then how two MAC address? One is the MAC address of this switch, the other one is the MAC address of this PC. You see, when we check this PC, we saw the MAC address is BC92. Do I see that BC92 here? Yes, I see. So this port has learned the MAC address of this as well as this switch. So the other one, BB02, should be the MAC address of this switch. Let's go and check. Show spanning tree. I think I should not see spanning tree. I should see some other. Show. I'll go to this port itself. Show interface F0/2. Let's see the MAC address there. The MAC address is BB02. I think, yeah, this is the one we saw on second switch. Yeah, correct. So this port MAC address and the PC's MAC address is reflecting here. Likewise, F01 of switch 2 has got show interface F0/1 6401. I'm expecting that here. Yeah. So switch 1 has already learned, before we ping, it has already learned the connected device MAC address. Switch 2 has already learned the MAC address of PC also. But what switch 2 do not know is the other two devices. Okay, now one disappeared because there is no active conversation. It's gone. Let me now try pinging. Ping 10.0.0.1. Also ping 10.0.0.2. What you can expect is the MAC address is fully learned. You see, this is the MAC address of the device connected around 03. 03 is connected to this. This is one. So the MAC address 1914, it will also be available on F02. 1914 will be also available on F02. Let's go and check. Yes, this is the MAC address of this PC, learned on both F03 as well as F02. When you ping from here, it needs to know the path. You see, on F02, there will be only one MAC address, F02. The hub don't have any MAC address. As a result, we have only one MAC address on F03. Oh, sorry, we need to check this. Only one MAC address. And this is the MAC address of that computer which is connected to the hub. You can see here 5844. You see, the MAC addresses are learned, and you can see more than one MAC address is learned on a port. There is no limit for number of MAC address. And I'm going to enable port security to limit this. I'm going to enable port security. If I simply enable port security, then only one MAC address will be allowed, and these ports will go to shutdown state. Which port? The port that has got more than one MAC address will go to shutdown state. Let's go and see that. I'm going to enable port security. Now, the port is in a dynamic auto mode. In this condition, if you say switch port security, it won't allow. The port need to be either in dynamic or, sorry, either in access or
Trunk or
trunk.
access. Access.
So I
Trunk.
say switch port mode access because I don't have more than one VLAN as access. Now when I say port security, show port security. I'm saying port security enabled on this port, only one MAC address can be learned at it. Maximum only one MAC address. Currently one MAC address learned. So what happens, when I ping, the second MAC address comes and the ping will fail. See, immediately the port has gone red. It says that the port has gone down. Change it down because of violation. Now if I check show port security, it says that violation happened. As a result, the interface is no more available for the packet forwarding. Show IP interface brief will show you that. The interface is down because of violation. Now to bring the interface up, what I need to do is, first of all, I need to fix the problem. What? I want to increase the number of MAC addresses to 2. Interface F0/1, switch port, port security, maximum 2. Maximum 2 MAC address. And then I have to shut down once and then bring it up. Now it will turn green. Not only that, when I ping, it won't go down because I have already said you can allow 2 MAC address. Let us go and verify this before pinging. Show port security. Two MAC address maximum allowed. Currently learned is 1. And now I'm going to ping from here. I'm able to ping. Now if you go and check the same command, the current will be also 2. So the ping is happening successfully. Now if I want to bind this MAC address, I can do it by copying from 2 places you can copy. One is show MAC table. From here also I can copy these MAC addresses. Or I can also say show port security addresses. In here also you see the same 2 MAC address. But here it says dynamic configured. It's not statically given. It's not manually configured. It's dynamically learned. I can say no, I want to give it hard coded. Right now it is a safe environment. I can copy and paste, which cannot be done later. So I say switch port security, MAC address. This is 1. It says it is already there. So what I can do is I can shut down the port, and now I can give this MAC address and the second MAC address. So in a safe environment we can do this. Now no shut. So we have also specified which 2 MAC addresses we will allow. So it's not any 2 MAC address, only this 2 MAC address allowed. If violation happens, it is going to shut down. Show port security addresses. Right now it says Secured configure, not dynamic configure. Securely configure. So what I'm going to do is I'm going to add another device. This device MAC address we have not attached here. And I'm going to shut down this. We say 2 MAC addresses allowed. And we also say which 2. So there is one computer with a wrong MAC address with the same IP 10003. Someone brings their computer. They are trying to spoof. It's not genuine, it's rogue 1000. So his intention is to gain access. Now as soon as this tries to communicate, see what happens to this green mark. It's learning actually. The port is in learning state. Let's wait for the green. Okay, this is turned green. On switch 1, show MAC address table. I don't see this new MAC address, but I'm trying to now generate some traffic. One. See, immediately it has gone down. So, because you have said which 2 MAC address, even though the number of MAC address learned is not 2, it's shown as it is already learned because we have hard coded. So the rogue device will never be able to succeed. So we identify the rogue device, we shut down the rogue device, and then we go back to this switch 2, manually bring it up. After which, if you try pinging from here, the ping will happen. Let us wait for the port to come green. Hmm. 2, 1. I'm able to ping this time. Next is learning MAC address and sticking it. On switch 2, I'm going to increase the number of MAC address. Now it's no more a rogue device. I want to make him as a good device. Give IP address as 4, 5. So this MAC address will be sticked dynamic on F01. I say switch port security max. Right now we have given 2. I'm going to say 3. And then the MAC address for the balance 2 we have already given. I'm saying sticky. So you will see when this new device try communicating, we have given 10005. When this device try communicating, the new MAC address will be learned. See, it's pinging. meaning it is allowed. Not only allowed, the MAC address of this device will be now sticked permanently to NVRAM. Let's wait for this. Now if I say show port security MAC address, not my addresses, you will find that this MAC address is ticked. You can also see that in the running configuration. Show RAN. You can see the third MAC address which is ticked is also displayed here. Now if I say write to memory, it goes to NVRAM. And when you reload the switch, there is no shutdown button in this. But in the real world, when we disconnect the cable and unplug the cable and plug it, or I'll say reload, that MAC addresses will still be there because you got the addresses saved to NVRAM. So only this 3 MAC address will be allowed at any point of time. 3 MAC address, and we have also said which 3 MAC address. The 3 MAC address is also available in the back table. Show port security will also show that 3 is already learned, even though we have not done any communication. Show port security addresses will show those 3 addresses. Show run will also show that in the running configuration. Right, this is how we mitigate the MAC flooding attack. Do you have any question?
No, sir.
No. So this is not only applicable for routers or switches. This feature is also available on firewalls, Nexus, ASR, iOS XE, XR, all flavors of Cisco operating system. AAA stands for authentication, authorization, and accounting. Authentication is to check whether genuine conversation or not. Authorization provides the level of access for those who have authenticated. Some may have full rights, some may have partial rights. That is what authorization provides, the level of rights after they get authenticated. Accounting keeps track of all the activities the authenticated user carries on. Now, keeping track of what he's doing with the authorization he has got is accounting. So, just the authentication alone may not sometimes provide the security that you want. You may be willing to allow someone, but you may have some limitation. To set that limit, we need authorization. For example, if he's a supervisor, once he is authenticated as a supervisor, once he is identified in the user group called supervisor, he should be allowed to put all the show commands because he's a supervisor. But he should not be allowed to use the command config t, because if once he uses the command config t, he will be going and configuring routing protocols, IP addresses, and so on. But supervisor should not be allowed to configure. So authorization limits what the user can do. And based on the limit, what all he has done will be seen in accounting. To do these three things, we need an additional external server, maybe Cisco ACS, Access Control Server, can be used. Or you can use ICE, Cisco's ICE. Only then you will be able to do all these three. We are not going to deal with Cisco ACS or ICE. With switch and router, what we can do? We can do only authentication. To a very limited level, you can also do authorization, but we are not going to do that. Not necessary. That's security track. So we are going to do AAA. We are going to have radius or TechX or both as the method of authentication. If in case the TechX or radius fail, we want local method to authenticate. What do I mean by that? You see, using AAA is a centralized authentication, authorization, and accounting, meaning we don't configure users on every switches and routers. We configure it on a centralized server like what you see here in the picture, right? You got some servers, two radius server, two TechX server, and now whenever the workstation try to access any of the network device, the network device will go and verify the user with the TechX or radius. If this server permits, grants permission, only then the user can telnet or SSH or send the traffic through the switch. What if the radius and TechX server unreachable? See, when you have radius and TechX configured as AAA on a switch, without TechX and radius server, switch cannot allow anyone. So for some reason, if this link goes down here, no one will be able to access the switch or any switch in the network where the AAA is enabled. Because the switches will look for the authentication server. Because they're unreachable, the switch will not allow anyone to log in. Even the genuine administrator cannot log in if the servers are offline. So what we do is we configure a last resort, like saying, first you check the radius. If radius is unreachable, only then you check your TechX. If that is also unreachable, then use the local database. So locally, we will put at least one username and password so that at least one person in office will be able to log in and solve the problem. These are all the authentication methods. So the method one can be radius, two can be TechX. You always need to have local as the third method, so that if any of all of the server goes down or connection to the server goes down, still you will have the access using the local database, local username and password. So on every device, you are still going to have a local username and password, but you need not to have all 10 employees' user IDs and passwords, just only one for lost result for the recovery. So all the employees will be maintained in Radius and TechX. Okay, so when we configure, this is what the syntax that we need to follow. AAA authentication, when you want to authenticate, when log in. There are various options. You will see there. If you put question mark. This is only during the login time. Login where? How? Is it logging in via telnet or is it logging in via console? How we are going to log in? For all logins, then you say default. If you want to use authentication at AAA, if you want to use a AAA only for those telnet users, then don't give default. Give a name and call that name. Give a name and call this name underline with UI. Followed by the methods. Method 1, radius. Method 2, TechApps. Method 3, local database. All other things are not applicable. Those methods we don't use now. Right? So this is about using AAA. Let us do a small exercise. In our case, we are securing with AAA, and AAA is in a local subnet itself, local area network, same VLAN. So I don't have any gateway anywhere. I just got this IP address 10002. This is what I'm going to configure as a AAA server. If you go down here, you see AAA here. I'm going to on the service. For radius, this is the default port number 1645. And I need to tell the client name. Client name is not username. Client name is those switches which will use the AAA service. If any computer tries to log into the switch via console or telnet or SSH, the switch will go to the AAA server. So before the switch comes here, we need to tell the IP address of the switch. So further, I need to give IP address to the switch. I'm going to give IP address. Interface VLAN 1. Because all these computers are in VLAN 1, I'm saying interface VLAN 1. IP address 10.0.0.100. So this switch also needs, if I need to manage this switch, this also needs an IP address. Right. Now I would like to go to the server and try pinging those two computers before I configure AAA. Say ping The ports are in listening and learning state. Once it becomes green, the spin will happen. Oh, you know what? Because of port security, this is down. When I configure interface VLAN1, there is another MAC address for the virtual interface. So let me increase the
Oh, yeah, that's right.
MAC address on F01, switchboard port security MAC address 10. Sorry, maximum 10. Let me try pinging 200 first. Meanwhile, that will go up. Oh, not 20. Okay. So we have ping from here to switch 2. Likewise, switch 1 also. It's pinging. Now, what is next is the switches are reaching and server can reach switches. I can go and enable service. I'm saying radius clients are 10.0.0.100. The client name is switch 1. The password he will bring, the pre-shared key will be Cisco 123. Add. Likewise, I also have another client 10.0.0.200. Same radius is switch underscore 2. The password that he will be bringing is Cisco 123. So first of all, the clients and servers need to get authenticated. This is what very important. Otherwise, anyone can bring their AAA server and spoil our network. Now, after these two guys, client and service get client and server understand, accept each other. The clients, sorry, the users, what password they will be using. I have users like user1 password, user2 password, user3 password. Now, we did for Taka radius, let us also do for TechX. Yeah, the same client switch 1, 10.0.0.1. You will come with the password Cisco. TechX is using TCP, radius is going to use UDP. TechX does authentication, authorization, and accounting separately. Radius will do authentication and authorization accounting together. Authorization and accounting together. Authentication separate. So I have added this. One more client also will use TechX, which is I come with the IP address 10.0.0.200. Password is. So we got 4 different. Actually, it is 2 client. I think I made a mistake here. This is not 1. This is 100. This one I want to delete. So I should see 4. 100, 200 targets, 100, 200 radius. And we have 3 users and passwords. Right now, if I telnet from here, there is no authentication. Let's enable AAA new model. What? Oh my God. Command is not supported. It is okay. I know where it will be supported. Right. So let us go and configure AAA this. Host name I would like to give a switch underscore to. And I would like to ping, okay, interface VLAN 1, no chat, IP address is 10.0.0.200. And I would like to ping from here the server 10.0.0. Oof, it has to come back.
Control C doesn't
No.
work, isn't it?
Meanwhile, I'll go to the other switch 1, and try pinging from here, ping 10.0.0.2. Alright, I'm able to ping the server, which means the immediate switch also can be pinged. Okay, good. Switch 2 is ready. Now, let's enable AAA. AAA new model. This is the command that enables AAA. Next, AAA authentication. Authentication for logging, not enable mode. I'm doing it for logging in. If someone tries to log in, if I say default, it will be for all logins, telnet, SSH, console, everything. And if I want to enable only for telnet, I need to give a name. I'm saying tel. Next is group. I want to first use TACAX. If TACAX is unreachable, then I want to use radius. If radius is also unreachable, then I want to use local. So local, I want to use the username. I want to give username as 123. Password also 123. This is not the username and password which I have given in the AAA. So this won't work. This username and password won't work as long as TACAX and radius is available. So if TACAX denies an access, it won't go and check the radius or local. If only they are unreachable, if one is unreachable, it will check the next one. So what are we going to do next? We're going to bind this under the line VTY. This is the word that I need to call. Line VTY. Authentication. Login. Authentication. The word that I gave is TEL. TEL capital. Sorry, not default. Authentication TEL. Okay. Now, given the login method, what is next? On this device, we should tell where the server is. TACAX server is on 10.0.0.2. TACAX server host is in 10.0.0.2. The key that it is looking for is Cisco 123. Likewise, the radius my radius is not there. Anyway, it's not supported. Same like TACAX, you need to say radius server. Now, we have enabled TACAX. TACAX is the first method I have specified. So this is enough. Let us go and test it. I'm going to go here and say tell that it is asking the username. If I give 123, 123, definitely it is not going to allow me in. Not allowed. Because that is the last resort, meaning if only TACAX and radius is unreachable. Right now we have TACAX and radius available, so I need to say user 3, pass 3. I'm inside. Means radius has authenticated me. I'm authenticated via radius server. Yeah. If it's a real device, you will be seeing who got authenticated, but here it won't be shown. Let's say here show users. It says someone from 10.0.0.3 has logged in. It is not showing any username because you are not using the local database. Let me also tell it from here. Telnet 10.0.0.200 user 1 pass 1. I'm in. Now if you go and ask the switch who has logged in, it says there are two people, one from 10.0.0.5 and 10.0.0.3. It doesn't show the user because you are not using local database. Now in case, if the server is off, when I try telling you the username 1, it won't allow. Actually, I hit enter. It is searching. It is trying to go. It at last checked with the local database and it says local is not accepting this username. So when I say 123 1, 2, 3, it accepts me. Now it will go in. It has to finish two methods. Okay, now it has allowed me. The third method has allowed me. That's why it took some time. Right, so when the TechX and Redis is available, it won't go to the local. Right, so that's about AAA.